Hello, this is Malachi King. I'm going to be going over the problem, hopefully on the screen. Let me check to make sure it's actually on there. Yes, it is. Okay. So here is the problem we're going to be solving. We're going to be going over the mesh current method. So first off, let's just draw the circuit. And okay, so for mesh current, what you want to do is each inside loop where there's no connections, you want to draw a loop and then imagine that only that current is running through the loop. So you're going to do that for each one. So for this problem, we should have two. We're going to label this one I1 and this one I2. Okay. And then for these, for each loop, you're going to write a KVL equation. So we're going to just start at the bottom left corner of each. So for I1, it's negative 16 volts using the active sign convention. And then each resistor, you start at positive and go to negative. So it'd be plus 2 ohms times, and then we're using this imaginary current that's flowing through this loop. So this is just I1 because there's no in meddling with I2. So it's 2 ohms times I1, and then same thing for this one, plus 3 ohms. Because this one has I1 and I2 going through, we're going to put both of those. So right now we're in the I1 loop, so I1 is going to be positive. So I1 minus I2. And all that is going to be equal to 0 because we're back at the ground. Okay. And then we can go ahead and simplify this. Negative 16 volts equals 2 ohms. No, not equals. So this is plus 2 ohms times I1 plus 3 ohms times I1 minus 3 ohms times I2. Then combining, we have 5 ohms times I1 minus 3 ohms times I2. And we're going to split this to the other side with the zeros so it can be positive. So this is going to equal 16 volts. Okay, now moving on to I2. For each one, we can reset the resistor values, the polarity, to align with our current to make it active, active sign convention. So this was going from positive to negative from top to bottom, but now for I2, it's going to be going from positive to negative, bottom to top. So it's going to be plus 3 ohms times I2. I2 is positive this time, so I1 is negative, so minus I1 plus 2 ohms times only I2 plus 4 ohms times I2. And then we're going in from the positive side of the voltage, so it's plus 12 volts equals 0. We can go ahead and simplify this. So 3 ohms times I2 minus 3 ohms times I1 plus 2 ohms times I2 4 ohms times I2, a lot of I2s. 12 volts equal to 0. So combining all the I2s, 5979 ohms times I2 minus 3 ohms times I1 plus 12 volts equals 0. Let's flip that over to that side. 9 ohms times I2 plus 12 volts equals 3 ohms times I1. Then dividing by 3 ohms for both sides, I1 is equal to 3I2 plus 4 amps. So we can take this and plug it into the first equation. So we have 5 ohms times, this is I1, sorry, my handwriting kind of bad. And I1 is 3I2 plus 4 amps. Times 3I2 plus 4 amps plus or minus 3 ohms times I2 equals 16 volts. So 15 ohms times I2 plus ohms times amps is volts, so plus 20 volts. This is here. Minus 3 ohms times I2 equals 16 volts. And then combining, we have 12 ohms times I2 plus 20 volts equals 16 volts. So minus 20, 12 ohms times I2 equals 4 or negative 4 volts. Divided by 12 ohms, 12 ohms. We get that I2 is equal to negative 1/3 of an amp, or negative 0.33 repeating. Now we can use this value and plug it into the I1 equation because that's the relationship between the two. So I1 equals 3 times I2 plus 4 amps. And 3 times a third is 1, so this is negative 1. Negative 1 amp plus 4 amps. So I1 is equal to 3 amps. Okay, now we're solving for the voltage V right here. And the voltage V is equal to the voltage across the 3 ohm resistor. So we need to find the current running through it because V equals IR. We already know R, and we now know the I, which we can solve for. It's depending on which one you go with, you're going to get a positive or a negative answer. I'm going to go ahead and go with I1 minus I2. So it's going to be 3 amps minus 3. Actually, no, from here we can do node voltage. Sorry about that. Had to think about it. So which for node voltage, you do a KCL. So at V, we have 3 currents. We're going to set them all going outward. So we're just going to call this V1. So V1 has V1 minus 16 volts over 2 ohms plus, sorry, you don't even have to do no mesh current. I just want to show you how to do mesh current. V1 minus 16 volts over V1 going to ground, so it's 0, over 3 ohms plus V1 minus 12 volts, 4 ohms, and that's equal to 0. Now we can multiply all of these by 12. for the least common denominator. So that would be 6v1 minus 16 times 6. Let's do that real quick. 996 volts plus 4v1 plus 3v1 minus 36 volts. So 10v1, no, 13v1. Sorry about that. 96 plus 36, 103 minus 103 2, 1, 10, 13, 132, duh, plus 130, let me draw that, minus 132 volts equals 0, plus 132 plus 132, 13, 1 equals 132, 13 divided by 13, V1 is equal to, let's get our calculator, 132 divided by 13, 10.1538 volts. So we'll do 10.154. And that is how you solve for the voltage V. All right. Thank you so much. I hope y'all like this because I needed to have a good grade. So thank you. Let's end the video. How do I? Okay. Where's the, how do I stop it? There we go.